In this video, we're going to have a very brief refresher on redox reactions. If you are struggling with redox reactions, please go back and review some of the videos or material from Gen Chem 1. So redox reactions are reactions where electrons are transferred from one element to another. And you want to remember the acronym oil rig for this. Oxidation is a loss of electrons, so your element becomes more positively charged because electrons are negatively charged. Reduction is a gain in electrons, so your element becomes more negatively charged. And we talk about oxidation states when we talk about a redox reaction. An oxidation state is a way for us to follow electrons during a redox reactions. So if your oxidation state increases, that is, if you become more positive, you are oxidized. While if you lose or you decrease an oxidation state, you are reduced because you're becoming more negative. So if we look at sodium plus chloride going to sodium chloride, that's a redox reaction. Sodium is going from neutral to positive. It's doing that by losing an electron. The left side of the equation has an oxidation state of 0. The right state now has an oxidation state of plus 1. So it has been oxidized. Chlorine has an oxidation state of 0. And then, as a product, minus 1. So it has been reduced. And when you do redox reactions, you do want to split the reactions into the oxidation and reduction half. It's easier to look at. So oxidation has electrons as products, and reduction has electrons as reactants. Remember, they're gaining it while they're losing it on oxidation. And here, the numbers I'm showing here are your oxidation states. So just a very brief reminder. If an element is bond to itself or in its neutral form, it will have oxidation state of 0. Ions that are charged have the oxidation state of whatever the sum of the charges here are. So iodine is negatively charged, so I'll have a minus 1 oxidation state. Elements. If an element is neutral, their oxidation state must add to 0. Oxygen in a compound will usually always have an oxidation state of minus 2. Hydrogen in a compound will usually always have the oxidation state of plus 1. So minus 2 and plus 1, plus 1. There's two plus 1s here because we have two hydrogens. So plus 2 minus 2 is 0. Chlorine, negatively charged, so negative 1. Oxygen, we have 3 oxygens, so there's minus 2 from the 3 oxygens. Overall, this has a negative 1 charge. So from 3 oxygens, our total oxidation state is minus 6. Minus 6 plus 5 is a negative 1. And then hydrogen is plus 1. And then you just see, okay, which state has lost electrons? Well, iodine went from minus 1 to plus 5, so it was oxidized. Which state gained electrons? Chlorine went from 0 to minus 1, so it has gained electrons. And so these half reactions, you need to balance them, not only for the number of elements, but you also need to balance them for charge as well. For example, these are unbalanced reactions. Look at the oxidation. So you have minus 1 charge here, and then you have a minus 7 charge in total. So these reactions aren't balanced yet. And so to balance redox reactions, the first thing you want to do is assign your oxidation states. Then you split your reaction into your oxidation and reduction. Then you balance your elements. So balance anything other than hydrogen and oxygen first. Then if you have oxygens that need to be balanced, do it by adding water. After you've added water and your oxygens are balanced, you need to balance the hydrogens next, and do that by adding H+. There are certain times when we will be in basic solutions, and that will be stated in the problem. And so any H+ you add, you will have to balance with OH-. Then you balance the charge by adding electrons. And you have to make the number of electrons in your oxidation redox reaction the same. So you do that by multiplying one or both of your equations by a whole number, your lowest common factor. And those are the steps to balancing redox reactions. And we'll have some practice with that in class so you can get a hang of it. And then after that, you just add your reactions together to cancel anything that's the same, like your electrons, and that will be your final equation. And then you just make sure you did your work right. Just check to make sure everything's balanced. And that's it for this video. I will see you in the next video.